right, guys, so yesterday we started the law of sines and how we use that in order to solve triangles. And what we looked at yesterday is we looked at cases where the side lengths and the angle measures that we were given could only create one triangle. So it fit into one of those 5 triangle congruence categories that I'm just going to write really quick off to the side here. Side, angle, side, 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 angle, side, angle, 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 side, or hypotenuse leg. So when we don't fit into one of those, let's redraw our triangle A, B, and C. So what we're going to look at is something called the ambiguous case. That's what we're going to call something that doesn't fall under these categories of triangle congruence. More specifically, this happens when we are given side lengths A and B and the measure of angle A. So if these are the 3 pieces of information that I am given, I would see that I have a side, side, angle, side, side, angle, triangle. Well, side, side, angle is not one of the ways that we can prove congruence. So I have to look at what's called the ambiguous case to figure out, well, first, how many triangles actually can be created, and then how can I use that in order to solve the triangle. So the 2 options that we're going to have is if A is acute or if A is right or obtuse. So when we're looking at this, when A is an acute angle, I have to look at how A compares to the height of my triangle and how A compares to the other side length that I'm given. So what's going to happen is I'm going to have 4 different scenarios that could happen when A is acute. So angle A could be acute, and my side length A could be less than H. A could be equal to H. A could be between H and B. Or A could be greater than or equal to B. So these are the 4 different cases that I could have when I'm looking at a triangle with an acute angle A. So let's take a look. I'm going to redraw kind of what my triangle looks like in each one of these. So I have angle A, side length B, angle A, side length B, A, B, A, B, and I'm going to look at the height in each one of these. Okay, so if I have A is less than H, so my value of A is smaller than my height, I'm thinking I have this little A value here that can be anything that is smaller than that red height that I drew. And if you guys look, no matter where I swing this little A, it's never going to hit that base of my triangle. I'm never going to actually be able to close this triangle. So anytime that A is less than H, I'm going to be able to create no triangles or 0 triangles because A isn't long enough to reach my base. Now, if A was equal to H, so if I took my A value and I drew it just right down, oh no, sorry guys. So let's redraw this really quick. If I took my A value and I drew it right down that same line of H. And I looked at, okay, if A is this long, this is kind of the pathway. If I were to swing that A value, it's only going to touch right at that one spot where H meets the base of my triangle. So in this case, I am only going to be able to create one triangle. If A is between, so it's greater than H, but it's less than B, I'm thinking I need something that is kind of like right in that middle area there. And if I were to take this and I were to swing it around, what's going to end up happening is I'm going to be able to draw that A line in two different places. Because I'm less than my B value, I'm greater than my H value. So when I kind of make that arc and I swing it almost like you think like a windshield wiper swings, it's going to cross that base in two different spots. So I would be able to have two triangles here. And we're going to talk about what that means for solving here in a couple minutes. But right now, just think if your A value is between your height and your B value, then you're going to be able to create two triangles. And then if A was greater than or equal to B, so I'm thinking I have an A value that is either the same length or longer than B, and I look at that arc that I can make, I have an arc that's going to actually re-intersect with my triangle only at one spot. So I would have my A only hit at one spot, or else it's going to kind of go off and it's going to be on its own. So this one is only going to create one triangle. It's triangles. There's two. Okay. So when we're looking at this ambiguous case, I'm given A, B, and the measure of angle A. If the measure of A is acute, I could have 0, 1, or 2 triangles, and it depends on how A relates to my height and to the other side length that's given. Now, what happens when A is right or obtuse? So in this scenario, I'm only going to have two different options. So if A is less than or equal to my B value, or if A is greater than my B value. So let's take a look at these two options. So I'm going to have, so this is for right and obtuse triangles. So I'm going to go ahead and draw both just so that we can kind of see how it looks on each. But whatever outcome we determine is going to be true for both of them. So when I am given A is less than or equal to B, so I'm thinking I have an A value and it is anywhere on here as long as it is less than this line B. So if I look at how is this going to swing, if I'm thinking about it can go any direction, it can go any direction here, it's never going to hit that third side that we have. We're never going to close that triangle. So just like when A is less than H with an acute angle, if A is less than or equal to B in a right or obtuse, then we are going to have no triangles. Now, if A is greater than B, so I have this A side length and it just has to be greater than B. I'm looking at how does this swing around. Well, it's going to intersect with that third line at one point here. What happens here on this one? I have something longer. I'm thinking, how does this swing around? Again, it intersects at one point. So when A is greater than B, then we can only create one triangle. So we're going to go up and we're going to do the 2-word problem C and D, and we're going to look at what in the world does all of this mean and what happens when we have no triangles or we have more than one triangle that can be created. So let's take a look at C. So Maggie is designing a mosaic by using triangular tiles of different shapes. Determine the number of triangles that Maggie can form using the measurements A equals 11 centimeters, B equals 17 centimeters, and the measure of angle A equals 30 degrees. So I'm going to draw this triangle, A, B, C. Actually, I'm going to redraw it how I had it drawn down below. Sorry. A, B, C. So my B value is 17, A is 11, and the measure of angle A is 30 degrees. So looking right here, do I have one of my triangle congruencies? I don't. Again, I have that side-side angle. So I have to look at how A relates to B and how A relates to H. So remember, H is going to be my height right here. And I'm not given my height, so that is something that I might have to find. So let's look, how does this relate to our triangles down here? Well, right now, the only thing that we have all the information to find now is to see if A is greater than or equal to B and have just one triangle. So let's take a look. A is 11, B is 17. So right now we have that A is less than B. So now we have to see, okay, how does it relate to H? Is H greater than A? Is H less than A? Are they equal? So we have to find A, or we have to find H. So that's the first thing we're going to do, is we're going to find H. Well, if we're given that this is our value of H, I can say that the sine of A equals H over 17. And I can multiply both sides by 17 and find that H is approximately 8.5. So I'm going to compare 8.5 to my A value. Well, A is greater than H. So let's go back down to our chart and let's compare what happens when A is less than B but greater than H. So that happens in this third scenario here. A is greater than B but less than, try this one more time. A is greater than H but less than B. So I'm going to have two possible triangles. So I have two triangles. So let's go through and talk about how this works. How does it work when I have two possible triangles? So what I'm going to do is I am going to solve the first triangle just like normal. So my step 2 is going to be solve triangle 1. And it's going to be exactly what we did yesterday. The third thing is I'm going to solve triangle 2. And this is kind of where an interesting thing happens. When I solve triangle 2, what I'm going to need to do is I'm going to need to do 180 minus one of the angles that I found in the first triangle. So this works because if you guys think about it, if I am looking at my kind of a unit circle and say that I find that 30 degrees is another one of my angles. Well, since I'm working with the law of sines, I know that my values are cosine, sine. So where else is that going to be have the same sine value? Well, the same sine value is going to occur over on this other side where I have a reference angle of 30 degrees. Because now I'm going to have the opposite of the cosine value, but I'm going to have the same sine value. So when I'm using this law of sines, I could get the same triangle happening with my original angle and the angle that's supplementary to it. So, like if this is 30 degrees, maybe in my triangle, my second triangle has this angle here, which is 180 minus 30 degrees. So I want you guys just to keep this in mind as we're going through, and we're going to come back to it once we get to that second triangle. So let's go ahead and just like I said, we're going to solve this first triangle just like normal. So we're solving for the measure of angle B, the measure of angle C, and side length C. And we're doing triangle 1 and 2. So I'm just going to recreate that little box key that I created yesterday. But now I kind of have this double box because I have 2 triangles that I'm looking for. So triangle 1, solving just like normal. So if I'm solving for the measure of angle B, I want to look first, what do I know the angle and the side length of? Well, I know angle A and I know side length A. So I'm going to set this up with the sine of 30 over 11 and have that equal to the sine of B over my side length B, which is 17. So solving for that angle, I'm going to do my cross products. So 17 times the sine of 30 equals the sine of B times 11. Divide both sides by 11 here, and I get that the sine of B equals 17 times the sine of 30 divided by 11. And here's something we haven't done in a couple days is now we need to get rid of the sine of B, so I have to take the inverse sine of both sides. I'm taking the inverse, actually I don't want to write it behind, I'm going to write it in front, the inverse sine of both sides. And when I do that, when I type this right side into my calculator, I find that the measure of angle B is approximately 50.6. So I'm going to write 50.6 in here for the measure of angle B. Next, I can find the measure of angle C just by doing my 180 minus 30 minus 50.6. So the measure of angle C, 180 minus 30 minus 50.6 and get that the measure of angle C is 99.4. So I get 99.4 degrees. So I could solve for my side length C using my law of sines. So sine of 30 over 11 equals the sine of 99.4 over C. Then if I do my cross products and I divide by the sine of 30, I get that C equals 11 sine of 99.4 divided by the sine of 30, which is approximately 21.7. 21.7. So first triangle we have solved completely. So now here's where we're going to take a look at what we were talking about before. So in this triangle, the first angle that I solved for was B, and I found that that was 50.6. So what I need to do to find parts of my second triangle is I'm going to say now instead of the measure of angle B being 50.6, I want to look at the angle supplementary to it because that angle should have the same sine value. So I'm going to see, okay, the measure, oh no, I'm sorry guys, hold on one second. The measure of angle B in my second triangle is going to be 180 minus 50.6. When I do this, I find that the measure of angle B is going to be 129.4. So that's all I have to do to find this new measure of angle B. And now I'm going to solve this second triangle like normal. So now I could solve the measure of angle C because the measure of angle C should complete my 180 degrees here. So I'm going to do 180 degrees minus the measure of angle A minus the measure of angle B. So that's going to be equal to 20.6. 20.6. And now I can solve for my angle C just like I had done in the last one. So I'm going to say the sine of A over A equals the sine of my new C value over C. I do my cross products and divide by the sine of 30 and get that C is equal to 11 times the sine of 20.6 over the sine of 30. So C is approximately 7.7. So I know this is a lot of work, but we just found the two triangles that could possibly have these three original measurements given. Let's try another example together, and then I'm going to give you guys tons of time to practice the law of sines in general and some of these ambiguous cases on your own. So, determine the number of triangles Maggie can form using the measurements A equals 10, B equals 6, and the measure of angle A is 105. So I have my A, B, C, and C. So let's compare A to B and to H. So A is 10, B is 6, so A is greater than B. Well, if I look down at my ambiguous case chart, if A is greater than or equal to B, then we're only going to have one triangle. So we only have to solve for one triangle this time. So ta-da, we only have one triangle, yay. So I'm looking for the measure of, I'm gonna draw this in a different color because I feel like there's a lot of green going on right now. So I'm looking for the measure of angle B, the measure of angle C, and side length C, and I only have to do one triangle. So I can look at my law of sines to find the measure of angle B. So that I'm going to look at the sine of my angle A over side length A equals the sine of angle B over side length B. I'll do my cross products. So 10 times the sine of B equals 6 times the sine of 105. Divide both sides by 10. So the sine of B equals, hold on one second. I'm sorry, equals 6 times the sine of 105 divided by 10. And then I take the inverse sine of both sides. So I get that B, so the measure of angle B is approximately 35.4. Okay, so I could solve for the measure of angle C now. That's going to be 180 minus A minus B. And find that the measure of angle C is approximately 39.6. So B was 35.4 degrees. C is 39.6 degrees. And the last thing to solve for is our side length C. So again, I can just use my law of sines. I'm going to zoom in a little bit so we have a little bit more room here. So the sine of 105 over 10 equals the sine of 39.6 over C. Then I can do my cross products and divide by the sine of 105 and get that C equals 10 times the sine of 39.6 divided by the sine of 105. And this is approximately 6.6. All right, so I know that this is a lot of work and there's a lot of information, but I am going to give you guys today and tomorrow to keep practicing the law of sines, keep practicing this ambiguous case. Also tomorrow, remember that we are going to be doing a live class. So please come to class and ask questions, listen to your peers' questions, and just anything on this unit, anything about school in general, whatever you guys have questions about, please bring those tomorrow to class. I'm so excited to see all of you guys. So have a good rest of your day, and I will talk to you tomorrow.